Moving on to the sixth problem. Diagonal AC of parallelogram ABCD bisects angle A. Then show that first thing it bisects angle C also, and secondly ABCD is a rhombus. Now moving on to the solution. Now we are required to prove from the above figure details that AC bisects angle C. That means we need to prove that angle ACD is equal to angle BCA, and second thing ABCD is a rhombus. In order to prove that given parallelogram is a rhombus, we need to prove that all the sides of the parallelogram are equal. That is, AB is equal to BC is equal to CD is equal to DA. So let us move on to the proof. In order to prove this, let us consider two triangles, that is triangle ADC and triangle ABC. In both triangles, AC is equal to AC since it is a common side. In triangle ADC and triangle ABC, AC is equal to AC as it is a common side, and BC is equal to AD as in the parallelogram opposite sides are parallel and are equal. Similarly, by applying the same concept that in parallelogram opposite sides are parallel and equal, we can say AB is equal to CD. Therefore, here the three corresponding sides of two triangles are equal. So by triplets property, we can say that triangle ADC is congruent to triangle CBA. So here, by applying the concept that when two triangles are congruent, then their corresponding angles will be equal. Here we can equate angle DAC is equal to angle BCA. So let it name is as equation number 2. Now, as triangle ACD is congruent to triangle BCA, we can say the corresponding angles are equal. So here angle CAD is equal to angle BCA, and also angle CAB is equal to angle DCA. Now we know that as AC bisects angle DAB, angle CAD is equal to angle CAB. So as we know that CAD is equal to CAB, we can equate angle BCA is equal to angle DCA, which implies this can be written as angle ACB is equal to angle ACD. So here angle C is divided by ACE equally. So we can say that AC bisects angle C. This is what our first proof required. And secondly, we came to know that as angle ACB is equal to ACD and angle CAD is equal to CAB, and we can equate angle CAD is equal to angle BCA is equal to angle DCA is equal to angle CAB. So now by considering angle CAD is equal to angle DCA, and by applying the concept that sides opposite to equal angles are equal, we can say AD is equal to BC, and by considering the other two angles, that is angle CAD is equal to angle BCA, and applying the same concept that sides opposite to opposite equal angles or equal, we can say AB is equal to BC, as angle CAD is equal to angle DCA. The sides opposite to these angles are equal, which implies AD is equal to CD. Here in the parallelogram, the non-parallel sides are equal, so we can say that ABCD is a rhombus. This is for the required second proof. Moving on to 7th question. ABCD is a rhombus. Show that diagonal AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. Now moving on to the solution. He has given that ABCD is a rhombus. So let us assume that ABCD is a rhombus. We know the properties of a rhombus as all the sides will be equal. That is, AB is equal to BC is equal to CD is equal to DA, and diagonals bisect each other perpendicularly. So here the diagonals are AC, which will be perpendicular to BD. Now we are required to prove that firstly AC bisects angle A and angle C, and secondly BD bisects angle B and angle D. Now in order to prove this, let us follow procedure. Let us consider the rhombus ABCD, and initially let us assume that only AC as diagonal. So we consider ABCD is a rhombus and AC as diagonal. Now here if we observe, the rhombus is clearly divided into two triangles, that is triangle ADC and triangle ABC. Here in these both triangles, DA is equal to AB, as all sides in the rhombus will be equal, and DC or CD can be equated to BC, and here AC is common side for both the triangles. So here by triplets property, as three sides correspondingly in the two triangles are equal, we can say triangle ADC is congruent to triangle ABC. We know when two triangles are congruent, then the corresponding sides and corresponding angles will be equal. So here the corresponding angle DAC can be equated to triangle CAB, and also angle DCA can be equated to angle ACB. Here if we observe clearly, as angle DAC, here if we observe clearly, angle DAC is equal to angle CAB and angle DCA is equal to angle ACB. We can say that AC is bisecting angle A and angle C. Now this is what our first proof required. Now in order to prove the second proof, that is BD bisects angle B and D respectively, let us consider the same rhombus ABCD, this time with BD as diagonal. then we can say in both the triangles, that is triangle DAB and triangle DCB, AD is equal to CD and AB will be equal to BC. And here if we observe, BD is common side for both the triangles. So here, as three corresponding sides in both the triangles are equal, by triplets property we can say triangle DAB is congruent to triangle DCB. We know when two triangles are congruent, then their corresponding angles and corresponding sides can be equated. So here in triangle ADB, angle ADB can be equated to angle CDB. And also angle ABD can be equated to angle DBC. So here, as these two angles are equal, as angle ADB is equal to angle BDC and angle ABD is equal to angle DBC, we can say that BD is bisecting angle B and angle D. This is what our second subpart proof. Moving on to the 8th question. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that ABCD is a square, and secondly diagonal BD bisects angle B as well as angle D. Now moving on to solution. He has given that ABCD is a rectangle. So let us assume the rectangle ABCD according to the problem. We know the properties of rectangle as lengths will be equal and the breadths will be equal. Two opposite sides will be equal, that means. He also says that diagonal AC bisects angle A as well as angle C. So he has given that AC bisects angle A as well as angle C. So here if we consider angle A, angle DAB will be equal to, here if we consider angle A, here angle DAC will be equal to angle CAB, as AC is bisecting angle A, and also AC is also bisecting angle C. So we can say angle DCA is equal to angle ACB. Now he asked us to prove that first thing, ABCD is a square and secondly BD bisects angle B as well as angle D. So now in order to prove this, let us follow a procedure. Now in triangles DAC and triangle CAB, if we observe angle DAC is equal to angle CAB and angle DCA is equal to angle ACB, since it is given that AC bisects angle A and angle C, and in these two triangles AC is equal to AC, which is common side for both the triangles. So here the two corresponding angles and a side in both the triangles are equal. So here we can say, according to ASA property, triangle DAC is congruent to triangle BAC. So here, as two triangles are congruent, we can say the corresponding sides and corresponding angles will be equal. Therefore, the corresponding side of DA in triangle ABC is, or BAC is, AB. So here AD can be equated to AB, and DC can also be equated to BC, which are corresponding sides. So here initially we know that AB is equal to CD and BC is equal to AD. So here we can say, from these four relations, all the sides are equal. That is, AB is equal to BC is equal to CD is equal to DA. So here the given rectangle will be a square. Therefore we can say ABCD is a square. This is what our first subpart of the proof required. Here we proved that ABCD is a square. He asked us to prove in the second subpart of the proof that BD bisects angle B as well as angle D. So here we are required to prove that angle ABD is equal to angle DBC and angle CDB is equal to angle ADB. So in order to prove that, let us consider both the triangles, that is triangle ABD and triangle BDC. In this both triangles, as he has given ABCD is, as we have proved that ABCD is a square, in this both triangles AD will be equal to BC and also AB is equal to CD. Now as it is a square, we can say angle DAB is equal to angle DCB is equal to 90 degrees. As in square, the adjacent sides are perpendicular. Now the two corresponding sides and the corresponding angle in both the triangles is equal. We can say triangle ABD is congruent to triangle CBD. Now as two triangles are congruent, we can say the corresponding angles and corresponding sides can be equated. So here angle ADB is equated to angle BDC and also angle CBD is equal to angle DBA. Here as these angles are equal, we can say BD bisects angle B and angle D. This is what our second subpart of the proof required. Now moving on to the ninth question. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ, and show that, first thing, triangle APD is congruent to triangle CQB, and second, AP is equal to CQ. Third, triangle AQB is congruent to triangle CPD, and AQ is equal to CP. And lastly, he asked us to prove that APCQ is a parallelogram. Now moving on to solution. Let us note down the given information, that is ABCD is a parallelogram. Let us note on the properties of the parallelogram, that is AB will be parallel to CD and also AB will be equal to CD and AD will be parallel to BC and AD will be also equal to BC. Now he asked us to prove, first thing, triangle APD is congruent to triangle CQB. Second thing, AP is equal to CQ. Third thing, triangle AQB is congruent to triangle CPD. Fourth, AQ is equal to CP. And last, APCQ is a parallelogram. In the first thing, he has asked us to prove that triangle APD is congruent to triangle CQB. So let us consider both triangles, that is triangle APD and triangle CQB. In this, AD is equal to BC. As we know that ABCD is a parallelogram, opposite sides will be parallel and equal. And next thing, let us consider that AD is parallel to BC and BD as diagonal. Then we get angle ADP is equal to angle QBC, as AD is parallel to BC and BD is diagonal or transversal. We can say the alternate interior angles above the transversal will be equal. So we can say angle ADP is equal to angle QBC, as they are alternate interior angles. Now he has already given that BQ is equal to DP. Now here, if we observe, in both the triangles, the two corresponding sides and included angle between them is equal. So we can say by SAS property, both the triangles are congruent, that is triangle APD is congruent to triangle CQB. We know that when two triangles are congruent, then the corresponding sides and corresponding angles can be equated. So here the corresponding sides AP can be equated to QC. This is what our second subpart of proof required. Now in the third bit, he asked us to prove that triangle AQB is congruent to triangle CPD and AQ is equal to CP in the fourth bit. So in order to prove this, let us consider both triangles, that is triangle AQB and triangle CPD. In this, AB is equal to CD. Since ABCD is a parallelogram, the opposite sides will be parallel and equal. And he has given that BQ is equal to PD, however. Now, if we consider that AB is parallel to CD and BD as diagonal, then angle ABQ will be equal to angle PDC, since they are alternate interior angles. Now the two corresponding sides and the corresponding angle of both the triangles are equal. Therefore, by SAS property, we can say triangle AQB is congruent to triangle CPD. When two triangles are congruent, we can say the corresponding angles and corresponding sides can be equated. So here CP will be equal to AQ. This is for the fourth subpart of proof required for us. Here also we can equate the two corresponding angles, that is angle AQB is equal to angle CPD. Now if we consider line BQD, here angle AQB and angle AQP form a linear pair. So we know that sum of angles on a linear pair is equal to 180 degrees. We can say angle AQB plus angle AQP is equal to 180 degrees, and also angle here if we consider line QPD, also angle QPC and angle CPD form a linear pair. So sum of angles on a linear pair is equal to 180 degrees. As both angles are equal to 180 degrees, we can equate angle AQB plus angle AQP is equal to angle QPC plus angle CPD. From the above, we can say that angle AQB is equal to angle CPD, so that can be cancelled on both sides. Then we get angle AQP is equal to angle QPC. Since angle AQP is equal to angle QPC, we can say the two angles on either side of transversal QP is equal. That means here the alternate interior angles are equal if AQ is parallel to PC, and also we know that AQ is equal to PC. Now similarly, if we consider the first proof that triangle APD is congruent to triangle CQB, we can prove angle PQC is equal to angle APQ. So here also the two alternate interior angles about transversal QP will be equal. So we can say QC is parallel to AP, and also initially we got that QC is equal to AP. So here if we consider in the figure APQC, AQ is parallel to PC and AQ is equal to PC, and also QC is parallel to AP and QC is equal to AP. Here in this figure the opposite sides are parallel and equal, so we can say APQC is a parallelogram. This is what our fifth proof required. Now moving on to a 10th question. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. Show that triangle APB is congruent to triangle QCD. Show that triangle APB is congruent to triangle CQD, and second thing AP is equal to CQ. Now moving on to the solution. Let us note down the given information that ABCD is a parallelogram with BD as diagonal, and we are required to prove that triangle APB is congruent to triangle CQD, and second thing AP is equal to CQ. Now moving on to the proof. Let us consider both the triangles, triangle APB and triangle CQD. So here there are APB and CQD. In this, angle APB is equal to angle CQD is equal to 90 degrees. Since he has given that AP is perpendicular to BD and CQ is also perpendicular to BD. Now AB is equal to CD. As in the parallelogram, opposite sides are parallel and are equal. Now if we consider AB, that AB is parallel to CD and BD as transversal, we can say angle CDQ is equal to angle ABP, since they are alternate interior angles. So here in two triangles, the two corresponding angles and a side is equal. So we can say by ASA property of congruence, triangle APB is congruent to triangle CQD. Now this is what our first proof required, and now by applying the concept that the corresponding sides and corresponding angles of two congruent triangles are equal, here we can equate the two corresponding sides, that is AP is equal to CQ, which is what our second proof required. Moving on to 11th question. In triangle ABC and triangle DEF, AB is equal to DE and AB parallel to DE. BC is equal to EF and BC is also parallel to EF. Vertices AB and C are joined to vertices BE and F respectively. Show that quadrilateral ABED is a parallelogram, quadrilateral BEFC is a parallelogram, AD parallel to CF and AD is equal to CF. Quadrilateral ACFD is also a parallelogram, AC is equal to DF, and sixth, triangle ABC is congruent to triangle DEF. Now in order to prove this, let us move on to the solution. He has given that AB is equal to DE as well as AB is parallel to DE and BC is parallel to EF, and he also given that BC is equal to EF. Now he asked us to prove that first thing ABED is a parallelogram. Second thing, BEFC is also a parallelogram. Third thing, AD is parallel to CF and AD is equal to CF. Fourth, ACFD is also a parallelogram. Fifth, AC is equal to DF, and sixth, triangle ABC is congruent to triangle DEF. In the first thing, he asked us to prove that quadrilateral ABED is a parallelogram. in order to prove this, let us consider the quadrilateral ABED. In this, he has given that AB is parallel to ED and also AB is equal to ED. Since the opposite sides are parallel and or equal, we can say the given quadrilateral ABED is a parallelogram. In the second thing, he asked us to prove that quadrilateral BEFC is a parallelogram. Here he has given that BC is parallel to EF and also BC is equal to EF. So as the opposite sides are parallel and equal in a quadrilateral, we can say BEFC is also a parallelogram. Now, initially we proved that ABED is a parallelogram. So we can say from that AD is also parallel to BE and AD will be equal to BE. Similarly, from the second proof, that is BEFC is a parallelogram, we can say CF is parallel to BE and CF is equal to BE. So from these two, we can say AD is parallel to CF and AD is equal to CF. Here in the fourth one, quadrilateral ACFD is also a parallelogram we need to prove. So in the above, we got that AD is equal to CF and AD is parallel to CF. So we can say if in a quadrilateral the opposite sides are equal and parallel, ACFD is a parallelogram. Now, as ACFD is a parallelogram, we can say AC is equal to DF and also AC is parallel to DF from figure. Now from this we can say that AC is equal to DF, and this is what our fifth proof required. Now finally, in the sixth part, he asked us to prove that triangle ABC is congruent to triangle DEF. He has given that AB is equal to DE in the first case and BC is equal to EF here also given in the second case, and finally we got that AC is equal to DF from the fifth proof. So here, as three sides correspondingly in both the triangles ABC and DEF are equal, we can say triangle ABC is congruent to triangle DEF. This is what our proof required. Moving on to the 12th question. ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Show that angle A is equal to angle B, angle C is equal to angle D, triangle ABC is congruent to triangle BAD, and diagonal AC is equal to BD. Now moving on to the solution. Let us note down the given information that ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Now he asked us to prove that first thing, angle A is equal to angle B. Second thing, angle C is equal to angle D. Third thing, triangle ABC is congruent to triangle BAD. And fourth, diagonal AC is equal to BD. Now in order to prove this, let us extend AB such that CE intersects AB at E and thereby AECD forms a parallelogram. Now, as AECD is a parallelogram, we can say AD is parallel to EC and also AD is equal to EC. But we know that AD is equal to BC, which implies BC will be equal to EC now. Now, if we consider in triangle CBE, two sides are equal, so the angles opposite to that sides will be also equal. So we can equate angle CBE is equal to angle CEB. But here angle B and angle CBE form a linear pair. We know that sum of angles on a linear pair is equal to 180 degrees. We can say angle CBE plus angle B is equal to 180 degrees. Now, if we consider that AD is parallel to EC and AE as transversal, then angle A and angle CEB lie on the same side of the transversal. We know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can say angle A plus angle CEB is equal to 180 degrees. Now, as these two are equal to 180 degrees, we can equate them. That is, angle CBE plus angle B is equal to angle A plus angle CEB. But we know that angle CBE is equal to angle CEB, which implies angle A is equal to angle B. This is for the first part of our proof required. Now, if we consider that AB is parallel to CD and AD, BC as transversals, then angle A and angle D lie on the same side of transversal. So we know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can say angle A plus angle D is equal to 180 degrees and angle B plus angle C is equal to 180 degrees. As both angles are equal to 180 degrees, we can equate angle A plus angle D is equal to angle B plus angle C. Initially we proved that angle A is equal to angle B, so that will be cancelled on both sides. Then we are left out with angle C is equal to angle D. This is what our second proof required. In the third proof, he asked us to prove that triangle ABC is congruent to triangle BAD. In order to prove this, let us join AC diagonal and BD diagonal. Now, as he asked us to prove the congruency of two triangles, let us consider both the triangles, that is triangle ABC and triangle BAD. In these two triangles, AD is equal to BC, since he has given that ABCD is a trapezium in which AD is equal to BC, and we can say AB is equal to AB, which is common side for both the triangles, and also angle ABC is equal to angle DAB, since we got that angle A is equal to angle B for the trapezium. Therefore, by SAS property, as two sides and corresponding angles in both the triangles are equal, we can say triangle ABC is congruent to triangle BAD. We know that when two triangles are congruent, then their corresponding sides can be equated. So here we can equate the corresponding sides, that is AC is equal to BD. This is what our fourth proof required.